to all of you for joining me. So the presentation is about astronomical and optical phenomena in the sky. It's a quite ambitious title. And during this presentation, basically, I want to discuss with you a few of the things that we can see in clear skies with unaided eye, so naked eye, without the use of binoculars or a telescope, and under good observing conditions, such as the ones that we can enjoy in many of the trips we do with Ocean Wide, or that for those of you and myself including, who likes to be in the mountains, also the kind of skies that we enjoy in remote and beautiful places. So aiming to have some coherence in what I'm going to present to you, I divided the presentation into 3 blocks. A first block that I call the special phenomena. And I use the word special phenomena just because this, to observe these things, you either need to be lucky, you either need to be in the right spot, in the right place, at the right time, or because this phenomena happens so rarely that they are really special. They stand out from what we normally can see which is the next block, in the night sky. What we can see in the night sky. And finally, the third block of my presentation will be what we can see during the day, because the day also has interesting things to show. So the special phenomena section, I like to quote here Edmund Halley, an astronomer, famous for the comet Halley. He predicted when and where in the sky the comet will be visible in the 17th century, but also he was a sailor, and he did a few voyages in the South Atlantic. He was this close to discover South Georgia, and according to Edmund Halley, one of the most beautiful and noblest astronomy affords that we can find was the observation of a transit of Venus. So that's the quote, which I will start my description of some special phenomena in the sky. One of the things that we can see that happens rare enough, so we can see at least one good solar eclipse in our lifetime. It's a solar eclipse or the eclipses, unless you travel or unless you move in the world, or you use special aids, or you watch it through the internet. Normally, at least once in your lifetime, most of us have the chance to see a solar eclipse in the places where we live. So that's my first special phenomena. The second, I will say, the exceptionally bright comets. At least I think most of us have the chance to see one of these comets in our lifetime. And then I start to mention more rare events, such as the planetary transits, which these are phenomena when you have the disk of the sun, and sometimes the inner planets, so Mercury and Venus, they pass in front of the disk of the sun, like a tiny eclipse for Mercury and a little bit bigger eclipse for Venus. They don't cover the whole surface of the sun, but you can see these planets passing in front of the sun. That's what we call a transit, a planetary transit. And Mercury transits, you can see at least a couple of in your lifetime. Venus transits, they are more rare. They occur in pairs once every century. And I have sad news if you miss the last ones, because the last ones happened in 2012 and 2008. And the next one is happening until 2117. So if you didn't see the transit of Venus, the pair in at the end of the first decade of 2000, then it's, unless someone invents a vaccine that makes you, or some mechanism to make us live longer than a century, then you miss the chance, and the only thing you can see are pictures. Then there are more rare events in the sky, like visible supernovas. They occur on average once a century. The last one visible from our Earth with unaided eye happened in 1987 in February in the southern hemisphere. And I will say this is when things start to get not good for us. If a supernova happens, should a supernova happen close to our planet, I think that's not good because supernovas are normally the end point of a massive star, which ends in a giant explosion, probably the most violent explosion that we know in the universe after the Big Bang. The explosion of a supermassive star, it's a supernova, and this is a deadly event for many planets. All the systems around a supernova collapse, and many of the systems in a radius of a few light years or thousands of light years, hundreds of light years away from the exploding star can have problems. So that's no good. And then we can witness also every now and then, every few tens of millions of years, we can witness the pass of a big meteorite or asteroid. And this is a very rare event. The very big ones are really, really rare. One of the biggest ones that happened in the last and very famous is the one of the dinosaurs. This one happened 65 million years ago, and that was big enough to provocate a massive extinction event in our planet. So that is not good. But normally we get hit by smaller asteroids, and I'm going to discuss all these phenomena in the next slides. So starting with eclipses, one of the most remarkable of all these special phenomena is the solar eclipse. The solar eclipse happens just because by chance, first of all, we have a moon, we have our moon, and it happens that our moon is 400 times smaller than the sun. But it happens that the sun is casually 400 times more far away than the moon. So by pure chance, nature gave us this geometry, the geometry between the sun, the moon, and the orbit of the Earth, and the orbit of the moon, respectively. And because by this chance, the moon manages to cover the disk of the sun when the conditions of the orbits are right. So we can have three types of solar eclipses. We can have the most beautiful one, the most spectacular, like the one happening in Antarctica in December this year, is a total solar eclipse, which happens when exactly the distances between the Earth and the sun and the moon and the Earth are right enough so the moon can cover the disk of the sun entirely. And we can have darkness, a brief moment of darkness. And what we call the umbra, the very dark path of the shadow of the moon, manages to touch the surface of the Earth and manages to cover a significant region of the Earth. These are the most beautiful of the solar eclipses. And they happen, a couple of them happen per year in our planet. Normally one at lower latitudes somewhere in the world, in the habitable world, and the next one or another one at higher latitudes in remote regions like the polar regions, like the one in Antarctica this year. The second type of solar eclipse is when the geometry is not right enough and the moon is not, we are far away from the sun, the moon is far away from us, and then we cannot, the moon cannot cover entirely the disk of the sun. And when that happens, we say the eclipse is not total, it's an annular eclipse. And sometimes, depending on the geometry of the orbits, it can be a total eclipse at the beginning and it can evolve into an annular eclipse, or it can start as an annular eclipse and end as a total eclipse. So this is the second type of eclipse. The moon does not manage to cover entirely the disk of the sun. And then we see this kind of like a black egg. Sometimes some astronomers call it like that, like an egg with a black yolk. So the disk is not covered entirely. The third one is the most simple one, is a partial solar eclipse. And this is when the conditions are not quite right to cover the entirety of the disk of the sun. And then we can see part of the disk of the sun covered. And this is when we have a partial eclipse. And this is also a very common eclipse, type of eclipse. And I'm sure some of you have had a chance to see a few. Some of you were with me once in Ortelius. We were in the Weddell Sea and we managed to see one partial eclipse that was... The timing was perfect because it was exactly before dinner. So we managed to see the partial eclipse and then we went for dinner. And they happened many times, a few times per year. and they are not so difficult to observe. This is the view, by the way. I like to share with you some great pictures that astronomers or astronauts or professional or really good amateur astrophotographers have taken. And this is a good picture. This is how an eclipse looks from space. It looks like a elliptical shadow that moves across the disk, across the surface of the Earth. This was taken from the International Space Station during a total solar eclipse that happened a couple of years ago. And this is also how a solar eclipse looks like from above. This is the one from December the 4th, 2021, this year in Antarctica. You can see the shadows, the very big shadow. That's what we call the penumbra. It's not so dark. And then you can see a very tiny black dot that appears along the area where I have the mouse. It's coming again, and it's going to appear now. And you can see, I will follow it with my mouse. This is the area where the totality happens. And this is the area where if you are standing below this dark shadow, then that's the area where you can witness a total solar eclipse. The time that I show here is the UTC time. So the eclipse happens quite early in the morning for those who hopefully will be, those of us hopefully that we will be witnessing this eclipse on December the 4th, 2021. So this is just a brief description of the first of the special phenomenon. Another special phenomenon that is beautiful also to witness, and that we have seen a couple during trips in Antarctica, are the lunar eclipses. Lunar eclipses are quite more common. They happen also a couple of times per year, but they are more common because simply the shadow of the Earth is much, much bigger than the shadow of the moon. So the Earth is much, much bigger than the moon. Therefore, the shadow is bigger. So most of the times, the shadow manages to cover the moon in a total solar eclipse of the moon. In a total lunar eclipse, And then when the shadow manages to cover the whole moon, because the shadow of the Earth is so big, the whole area that has the full moon over the horizon of the world can see the eclipse. That's why it's more common, because more people have access, have the chance to see the eclipse. Simply, everybody that has the full moon at the right moment where the shadow of the Earth covers the moon, then everybody can see the eclipse. And this is an animation. Of course, you can have also the misalignment of the shadow, and then the moon cannot be completely covered, and then you have a partial lunar eclipse. And a lunar eclipse looks like this. The moon enters the penumbra, the big disk, and then eventually enters the gray disk, which is the umbra, the really dark area of the shadow, and then the moon is completely covered. What is very interesting and beautiful to see in these eclipses is the colors that the moon gets. Normally, you have a full moon, and suddenly you see like this is like Pac-Man. Like if you play with the games, the video games from Atari back in the day in the 80s, it's like someone is eating the moon. Someone took a bite of the moon, and then the moon starts to disappear, the full moon, and eventually the moon becomes a bit reddish. And a good indication, the color red gives you a good indication of the quality of the atmosphere, how many particles are in your atmosphere, and also if there were, for example, eruptions. Like I remember there was a total lunar eclipse after the Pinatubo eruption that happened in '89, and there were lots of ashes in the high stratosphere, and those particular years after the eruption of Pinatubo made the moon really red during the total lunar eclipses. So that's something really beautiful. Also, if you are in very dark places like at sea, and if you witness one of these lunar eclipses, total, you can witness the moon becomes like a sphere in 3 dimensions with really beautiful colors, reddish, or if it's quite clean, if the air is quite clean, you can also enjoy wonderful tonalities of grays and blues, and it's quite spectacular. At the end of the presentation and at the end of afterwards, I will send to you some links where you can access to information about the upcoming eclipses, so you can have an idea of what to observe. Here, I'm going to jump into the next interesting special phenomena, which are the planetary transits. This is quite a very interesting phenomenon because they were predicted theoretically by Johannes Kepler. Johannes Kepler, back in 1600s, he published some tables that are called the Rudolphine tables, which were some sort of mathematical tables that allow you to predict where the planets were going to be in the future, or you could use the same tables to, like a time machine, to reproduce where the planets were in the past. This was the first time in history that we had access to this kind of knowledge, thanks to Johannes Kepler. And he predicted the possibility that Mercury or Venus, the planets that are between the Earth and the Sun, sometimes, on very rare occasions, they can pass in front of the disk of the Sun. And this is the idea of the planetary transits. So he published these tables, and he made some announcements that a few transits were going to be visible. And indeed, the first person to see a transit was a priest in Italy, Gassendi, who managed to see at least among the ones that we know. And he managed, after using these tables from Kepler, to watch Mercury passing in 1631 in front of the disk of the Sun. This is the picture on the left is the transit of Mercury. I had the chance to witness with my students in Guatemala City when I was teaching at the university in April 2016. And I leave to you, I'm going to show you in the next slide, but meanwhile you can think which of these dark spots that you see here, which one do you think is Mercury? And on the right picture, this is a picture where I'm showing you here the transit of Venus. I had the chance to organize a small trip to Anchorage, Alaska in 2012 to observe the transit of Venus. And this is Venus here. I'm not going to ask you, it's too obvious, it's too big. And this is Venus passing in front of the disk of the Sun. The first person to see a transit of Venus was a Britishman. It happened it was Jeremiah, I forgot his last name, but it was a Britishman who in Manchester, nearby Manchester, he managed to observe the transit of Venus. Jeremiah Horrocks was, and if you are in Manchester, if for those of you who are on board on this trip from England, the next time you have the chance to visit Manchester, if you can visit the municipality of Manchester, the city town hall of Manchester, inside the city town hall there is a little painting where you can see Jeremiah observing the transit of Venus, and he was the first person in history to observe the transit of Venus of 1639. The transits of Venus are connected to us somehow because a few of the places that we visit during our trips were places that were visited by astronomers aiming to witness transits of Venus, such as Molte Harbor in South Georgia, because I have some interesting news for you and why transits of Venus were so fascinating for astronomers and for our knowledge in the past, because it's thanks to the transits, to the measurement of the duration and the geometry of the transits of Venus, that we as people, as mankind, for the first time, we managed to measure the distance between the planets of the Earth, therefore to understand the true size of our solar system. That's one of the reasons why transits of Venus are so special for astronomers, because they gave us the chance to measure for the first time the distance between the Earth and the Sun, and also the distance between the other planets, thanks to the Kepler's laws. So that's one reason. And the other reason I like to mention, which is important about transits of Venus, is that they were the first time that really there was international cooperation, international scientific cooperation. Many of the transits happened during the 30-year war, for example, and French and English were not so happy together. But nevertheless, French astronomers were granted permissions by the British government to be able to witness and to record the transits of Venus. And also British astronomers were granted by the French permissions to move to be able to watch transits of Venus. It was another level of understanding and a good commitment to try to understand the size of our solar system and the mechanisms, the mechanics of the movements of our planets. So those are just two examples of how and why transits of Venus are so nice. So while I was talking too much, I hope you were trying to spot, this is Mercury in 2016. In the transit that we had the chance to see, and this is Venus. Obvious, you can still see some fuzziness around the very black dot at the center, and this fuzziness is a bit of the atmosphere of Venus. That even with a small telescope, I was using a very small refractor at Anchorage when I did these pictures in 2012. So those are really remarkable events, and as I mentioned, a few of the places that we visit are connected to old expeditions. Even Ushuaia and other of the South Atlantic islands in the South Atlantic, like Ascension and Santa Elena, are really connected to people who in the past were trying to measure the distance between the Earth and the Sun, thanks to the transits of Venus. So let's move on. Sadly, the next transit of Venus happens until 2117. I think none of us will be around here. And the ones of Mercury, there are a few of them every 15 years. So I will send you details about the next one. So in case you want to see these events, by the way, they require, as well as the solar total eclipses, they require some minimum safety. They are really dangerous to see if you don't wear the right equipment, protective equipment for your eyes, because watching the sun is really dangerous if you don't do it right. So bright comets are another of the special phenomenon. We had the chance, if you miss a few of the previous comets last year, we had the chance to see this comet. The name is horrible. It's not anymore Comet Turner or Comet Kurze or Comet Low or Comet Halley. This is Comet C2020 F3, and that's because it's a machine. It's the Neowise machine. It's a very special and sophisticated camera devoted to spot comets that discovered the comet. And this was a comet that was coming from the depths of the solar system, and we had the chance to see it here on Earth last year. And if you miss it, don't worry, because every now and then there are very beautiful comets passing by the Earth. You can see here the comet, I hope, the tail and the coma and the nuclei of the comet. So comets are basically masses of gas that, as they move, they approach to the sun heats them up, and then they start to evaporate. All this ice and all the gas is released, and then they produce tails, and you can see these beautiful tails. As you notice, I am not giving so much emphasis on the detailed descriptions of every of these phenomena. I want to give a broad picture because I want to make this fun, and moreover, time. We could speak about comets for days, as well as eclipses and transits, but I want to keep it short so you enjoy and you can have a broad picture of what the sky has to offer us. So let's go to more rare phenomenon, and I want to show you here. This is a picture taken by the Anglo-Australian Observatory of the supernova of 1987A that happened in the constellation of Doradus in the south, in the large Magellanic Cloud. And this is the picture in this area. You can see the picture before the explosion, and this is the picture during the explosion. The star became so bright that it was visible by naked eye. And today we know that probably there is a neutron star, the debris of the star. It's at the center of the explosion. This was not so big to produce a black hole. And the beauty of these explosions is that during these explosions, the heavy elements of the periodic table, like the elements that make our blood, for example, iron, elements such as gold or silver, which for some people are precious metals, all these heavy elements are produced during these explosions. So we are dust of these explosions, and that's the beauty behind these cataclysmic explosions in the sky. Supernova 1987A, so it was visible by the naked eye. It was not only in the southern hemisphere, and I think one of the reasons I decided to become an astronomer was because with my father, I was 8 in 1987, and we tried to see the supernova, but sadly, for the location where we were in Guatemala, theoretically it was possible to see it, but because it was too low in the horizon. In Guatemala, we have too many volcanoes, so the supernova was just hidden by a volcano in the horizon, so we could not see it. But I got very curious about supernovas, and they are really rare events. I really look forward for the next one, and if there is one, probably you will hear from me sooner or later, because I will be jumping of happiness if another supernova happens. The previous supernovas visible, there are a few historical supernovas, but just from the 1500s forward, we have the supernova of 1534, the supernova of 1604, and the supernova of 1987. Really cataclysmic events, really massive explosions, and the beauty again is that they produce the heavy elements. So I forgot to mention, should a supernova happen close to the Earth, then we are in serious troubles, because the supernova normally releases also high doses of radiation, of harmful radiation, ionizing radiation, and lots of astroparticles. And these might be really harmful for life. Fortunately, we know the astronomers have measured the types of stars that might go supernova around the Earth, and we know for sure that there are no massive stars in at least a few thousands of light years around us. So we are safe, and we might not be harmed by a supernova explosion nearby, because there are no stars that are going supernova nearby the Earth. Nevertheless, in the past, there was a massive extinction event in the Ordovicus Siluricus time, geological time, many hundreds of millions of years ago. And some geologists and astronomers think that maybe this event, this massive extinction event, was produced by radiation from a supernova. It's one of the theories. It's not entirely verified, but it's one of the suppositions, given that there is a lot of heavy radioactive isotopes in a layer, in a strata, that might be only produced by the radiation from a supernova. It's just one of these ideas. Our friends, the geologists, Andreas and then Lawrence and Joachim might want to discuss this another time later. So let's go to more dangerous special events, more dangerous and more rare. The big impacts. We know for sure that in the past the Earth has been hit by big impacts. One of them probably caused the destruction of dinosaurs, or at least provoked a climate change big enough to change the major species that were on the surface of the planet at the time, 65 million years ago. And we know that this happens, and this is a video. I warned you that the first few seconds are a bit fuzzy. That's my computer, and I couldn't fix that. So don't worry about the green. It will be better in a few seconds if all goes right. I have tested this many times. Yes, so the video is running now. And this was by chance. A taxi driver that was driving his car in Chelyabinsk in Russia, when his camera was pointing at the right moment, at the right time, to the meteorite that hit Russia in February 2013. You see here, it was sunrise. The sun was still under the horizon, but you can see the twilight colors here, and you can see the meteorite. At the moment that the meteorite comes into the atmosphere and disintegrates, This was a small one. It was about 20 meters in diameter, the meteorite. But nevertheless, the speed of these objects really, they transfer, they have a lot of energy, which is transferred into the atmosphere, and they release really, really large quantities of energy. This meteorite, 20 meters, released something like 230 kilotons of TNT. So that's 10 times the bomb of Hiroshima. That's what you're seeing there. And because of the angle was so shallow, it managed to produce really large shock waves that hit many windows, and about 1,500 people were harmed by the shatters of the glass that were broken during the explosion. So this is just a small reminder that this is happening all the times. We have lived with this all our lives. Our species have had to survive. Somehow this impacts. I'm going to run it just one last time. You can see here the meteorite coming. And yeah, we know it happens. And thanks to different sensors that are located around the world, we know that this is not such a rare event. Here you see the larger the circle, the more energy the meteorite had. The color of the circle tells you if the detection was made during the day or during the night. In yellow is the day, in blue is during the night. And you can see it doesn't matter if it's day or night. And you can see also it doesn't matter where you are. It happens more or less evenly on the surface of the Earth. A little bit more across the equatorial latitudes, and not just because more of the debris that come to the Earth are also close to the equator of the Earth, because it's just the mechanics of the solar system. But you can see there are many impacts. And we as with our ships, we always have the chance to visit the remote regions. And in many of these remote regions where we go, there are many of these sensors, microphones that are constantly hearing for very low infrasounds that are produced when the meteorites come, or that are have enough sensitivity to detect the impact of the meteorite with the water or with the surface of the Earth, and to record somehow the explosion. And that's how also when a submarine implodes or when there are some explosive events, we can also know what kind of device was used or what happened with what produced the explosion. So this is just to give you an idea that people monitor this, and we have an idea. That's why the numbers, that a very big one is so rare, that happens once every few tens of millions of years. So that was my review on special phenomenon. If you have the chance to see any of these, or if you have had the chance to see any of these, you can like tick your lists if you feel like ticking your list of observations. Yeah, these are from my perspective some of the most rare things that you can see normally in the sky. So let's go now specifically to what we can see in the night sky. I'm going to describe just briefly a few of the things that you can enjoy by watching with your eyes up in the sky. And first of all, I need to make a remark and a couple of notes about how we, the astronomers, measure the brightness of objects. It turns out that the first person who tried to classify how bright were the objects was Hipparchus back in the day in the year 2 before Christ, before the Common Era, and he established a classification. So the brightest objects will be the lowest, will have the lowest rank on this system. And the faintest objects will have the highest number on this classification system. So this was used for hundreds of years. And the system uses something that we call now as a magnitude. So the lower the number, the brighter the object, and the higher the number, the fainter the object. So we talk about low magnitude and high magnitude. And this was okay because he said the brightest star, it will be 0, and then the second brightest star or the other smaller stars will be 1 and 2 and 3 and so on. But eventually we invented cameras, like film cameras or with plates. And then there was a gentleman, Norman Pogson, in 1856. He tried to make a revision of this system, and it turns out that a few of the stars that were magnitude 0 were brighter than 0. So he decided, okay, let's use negative numbers. And I apologize for that. Astronomers we are sometimes a bit confusing, and I apologize for that because it was impossible to change all the catalogs backwards. So he said, okay, let's use negative numbers. And it went go forward with negative numbers. And today we still use this system, the Pogson or Hipparchus-Pogson system. And then for the sun, just to give you an idea, is minus 26. And I have to tell you also the system is not linear. So by linear, I mean it doesn't go like 1, 2, 3, 4, but it goes on a logarithmic scale. So that means it goes 2, 4, 8, 16, 32, because that's the way our eyes respond to light. Our eyes don't respond linearly, but our eyes, so if you change the brightness between 1 or 2, our eyes cannot sense the difference between 1 or 2. But if you change the brightness of an object between 2 and 64, for example, then your eyes tell you, that's brighter. And that's how our eyes work, and that's why the system works with these crazy numbers. So I am giving you here a few ideas how bright are things, like the sun is minus 26, so it's the brightest thing we can think of. The full moon is minus 11, and then you have Venus, minus 4. The brightest star is Sirius, is minus 1,5. And then you have a very beautiful star, it's called Vega, and this is magnitude 0, and it's used to calibrate instruments because it's really, really close to 0. And then, for example, if you might wonder what is the faintest thing that a telescope can see, so for example, the Hubble Space Telescope is able to detect things that have magnitude 31. So it's really, really nothing compared to what we can see, and it's really like detecting. As I was reading once, one of these beautiful comparisons is like if you put a car very far away, like on the surface of the moon, and then you want to know if the light the turning light is left or right, and then the telescope can tell you if it's left or right. So magnitude 29 is really, really, really faint, and that's just to give you an idea how faint is for our eyes. So it's inimaginable faint, and that's why these telescopes are so expensive and so big, also like the ones in Chile. So they are able to detect these really faint objects. So I'm going to take you. I'm not going to describe all the objects because I think all of you know some of the objects that we see in the sky, and you know there are planets, stars, and a few things. I will do mention a few of them, but what I'm going to do is I'm going to take you through the night. So we will try to see what is interesting to watch between the sunset and the sunrise. Yeah. So first of all, I wanted to mention to you how we define night, when the night starts. So it happens that even for that, there are definitions. Municipalities need to know when is right to turn on the lights on the street, for example, and when is right to turn on the lights of your cars or your bikes in Holland, and that's what we call the civil twilight. So as soon as the sun sets, you have a period of time that normally depends where you are in the world. It can last for a few minutes to a few tenths of minutes. It's the civil twilight, and it's the moment between 0 degrees, so the sun is at the horizon, and the moment between the moment that takes the sun to go 6 degrees below the horizon. more or less. And that's the moment where in most of the cities and in most of the civilian establishments, lights should be turned on, and that's the civil twilight. As the sun goes deeper, the sky turns a bit darker, and the brightest stars commence to appear in the sky. And you have two things that are important. You can have stars in the sky, but you still can see, for example, the horizon. And this is what we call the nautical twilight. And it's the moment between the civil twilight, so between the sun is 6 degrees below and 15 degrees below. And that's the moment where you can still see the horizon and you still see some bright stars or some, bright stars. So that's the moment in the old times where sailors used to take a sight with a sextant. So they used to take a star, because to use a sextant, you need to have an horizon, but you need a star also. So you could do a sight of a star using the sextant. And that's why it's called nautical twilight. So as the sun goes deeper, the colors change, the more stars appear, and the sky becomes like a bit like bluer, dark blue, even black, not deep black, but relatively, or dark gray, I will say. And then that's the moment where in astronomical telescopes, you start to calibrate instruments. I used to work a few years in La Palma, in the Canary Islands, at a telescope, and then that was the time when we had to have the telescope ready to operations, and that's the time when we started to calibrate cameras or spectrographs or whatever we were measuring that day. We were going to calibrate instruments at that moment, and then after the sun reaches between 18-20 degrees below the horizon, you have the shadow of the Earth covers entirely the sky, and then the sky is dark enough to see really faint stars with your eyes. And you can no longer, for example, see the horizon. And that's the time, for example, when in a telescope you start to collect data, or when you really can see and undertake astronomical observations with binoculars or with your eyes. So this is what I'm trying to describe here. I made this picture sailing somewhere between, en route to Santa Elena, somewhere between South Africa and Santa Elena. And this is the kind of feature I am talking to you. This is looking in the opposite direction of where the sun sat. So the sun is on my back when I did this picture. But what I want to show you here is a few beautiful things. The first of all is the color, that there is like a whitish blue really high above the horizon, that is like a shade. Then you start to have a layer of pink, like a layer of orange pink, and that's called the Venus belt, because it's like the frontier between the night that comes below. You can see above the horizon is really, really dark. That's the shadow of the Earth, and that's the moment where the night comes, and that's the frontier between the two. And that's the beautiful picture. So when you are looking at a sunset at sea, for example, this is the kind of things that you might like to know: the colors, the civil twilight, the belt of Venus, and the different tonalities of colors that you can enjoy in the sky. That every color depends on how deep the sun is below the horizon before the night. So once the sun, we reach certain darkness, as I mentioned before, we start to see the brightest objects. And normally the first things to appear are the brightest stars, but close to the horizon, normally close where the sun sat. Normally there are two planets that can be visible around us, those areas, always after the sunset or before the sunrise, and those are Mercury and Venus. And those planets, because they are too close to the sun, they can be visible only after the sunset or before the sunrise. And they are really bright. Venus is one of the brightest things in the sky after the sun and the moon. And it's so bright that it can make shadows. And for example, I have seen, sounds crazy, but in cities, even if you are in a dark place, or in rural areas, in towns, within Europe, or in many of the Western areas, there is so much light pollution that even you cannot reach really the darkness that you can enjoy at sea, for example. And in a ship, I had the chance to see my shadow being casted by the light of Venus. That sounds completely crazy, but Venus can be so bright that you can see shadow, but you need to really be in very special places. So, like if you are in a ship, like us at sea, where it's really, really dark, you have no light pollution whatsoever around you. That's something enjoyable that you cannot see anywhere else. The shadow of Venus, the light of Venus, of shadows made by Venus. So also sometimes, depending on the time of the year, there are other bright planets like Jupiter and Saturn and Mars that can be also around. And normally they are in a line that I will explain later better. Is called the ecliptic, and it's the line, the plane of the solar system where all the planets and all the moons move. And is you can think of as if you expand the equator of the sun to infinity. You take the half of the sun and expand it to infinity. That's the plane where all the planets more or less move, and the moons, and that's where you will find always bright planets. So if you see a line of planets, as I will show you later, that means you're looking, or a line of bright objects, that means you're looking at planets probably, and you're looking at the ecliptic. So after the sunset, and suppose we saw the beautiful colors after the sunset, we saw the process of the twilight, the dusk, the dawn, etc. The dusk colors. You can see the planets, you can see these inner planets. But normally a couple of hours after the sunset is the right time to be able to see satellites. And that's another very interesting thing to see. If you don't know what you're looking and you see a satellite, you might think, oh, I'm looking something really spooky here. Because satellites, normally they move in really straight lines. They move quite fast in the sky, a bit faster than a plane. They can be really bright sometimes. And what is important is that they don't have any navigational light. So they are really, really interesting to see. And for that, I have here a little movie which shows the path of the International Space Station. Here you can see it passing really quickly above the sky. And again, it has no navigational lights, and it can be really, really bright, and much, much brighter than this video. I remember seeing it once, and it was really, really, you could see your shadow because it was too bright. Remember, satellites are made of very sophisticated materials, most of the times metals, precious metals, and these materials reflect the light of the sun. And they travel so high that there are 2 times in the day, like between 1 and 2 hours after the sunset, and between 1 and 2 hours before the sunrise, where the angles are right, so the satellite can reflect light, inclusive the International Space Station, which has a huge solar panels. So this is the right moment to observe satellites. If you want to know what did you see, it's always good to annotate the time and where in the world were you, because you can always find later what did you see. There is a nice website I'm sharing with you here below. The website is called Heavens Above. It's a really nice website where you can enter your location and you can see predictions, past predictions or future predictions of what you expected to see in the sky regarding satellites and space debris. And you can print, for example, a map. I made this one, for example, for tomorrow where I live. I live in a town called Lenzburg in Switzerland. So I gave the location. And for example, tomorrow, if I wake up at 5 in the morning, I might be able to see the International Space Station passing by above my home. So you can do that. At the end, I'm going to, after the talk, we will send you an email with information as Andreas did. And then you can find this website and play with it. Important to know, remember the brightness. So if you see a negative number, as I'm showing you here with the mouse, negative number just means really bright. And that's what you want to see, something really bright and so obvious that you cannot miss it. So that's just an example of the possibilities of these maps. So the night sky offers you really interesting things to observe. And probably one of the most beautiful things to watch are the stars. Regarding the night sky, I want to tell you the sky. I don't know why humans we like borders and to control everything with the divisions, but we divided the sky into sections, and each of these sections is called a constellation. Originally, there were 48. Historically, for historical reasons, we use the Greek names, but if you are with the Chinese charter, you might want to know a few of the Chinese constellations because they had older charters than the Greeks. But sadly, we use Greek, so they get a bit annoyed when when they hear the Greek names because their astronomers did charts for thousands of years before the Greeks. But we use the Greek names, and originally there were 48, but today we have 88. So the whole sky is divided into 88 sections. And I don't want to recite you all the 88 constellations. You can find that out in the internet in many wonderful places. But what I want to point to you is the constellations can be divided into 3 sections. You can think of the northern constellations, the zodiac constellations, and the southern constellations. The zodiac constellations are the ones where the sun, the moon, and the planets move, and they are really important. Originally and historically is the ones that the astrologers used to use to do the horoscopes, but they forgot that the Earth moves. The Earth has very interesting movements, and some of the old charts are no longer valid because the whole sky has moved. The whole Earth moved given the movements of the Earth. So it's important to remember these 3 types of constellations, and some of them are quite useful to find your places where you are, or at least some geographical points. At sea, again, the sky is absolutely fantastic if you have the right conditions. And I will encourage you, I am really happy to help you when we are on board to at least learn a few of the big constellations, because normally they help you to find the other ones. And there are a few that are really remarkable because they have very bright stars and the shapes of the constellations are easy to remember. One of them is Orion the Hunter, famous because it has the belt and 2 very bright stars, Betelgeuse and Rigel. Another one is Cassiopeia. It's not too bright, but the shape is the shape of a W or an M, so it's easy to remember. And then you have the bears, the big bear, the little bear, in the north. In the south, you have the Southern Cross and constellations like Scorpio. And as I said, they can be used as a waypoint to find the other constellations and then to build eventually the chart of the whole sky. Important to know is that the moon, the planets, and comets often are along the zodiac, along the ecliptic, this line which is composed by 12, 13 constellations, and the planets will be always along those constellations. So let me just point out you a few things that I think are remarkable and good to know. One of them is if you manage to identify, for example, Ursa Major, the Big Dipper, you can use it to find Polaris. Polaris is basically 5 times the distance between these 2 stars, Alpha and Beta Ursa Major. If you take this distance 5 times, you will hit Polaris. And the alignation, the way the 2 stars are aligned, it points you. That's why they call them the pointers, because they point you towards Polaris. If you manage to find Polaris, another good trick to know is that Polaris is somehow between the Big Dipper and Cassiopeia, that is the M, and that they follow each other, never touching, during the night. So if you have a clear night at home, you can use some of your time to identify a few of the constellations, and you will notice that between the 2, the Cassiopeia and the Big Dipper, there is a star that barely moves during the night. If you start to observe it at 8 o'clock in the night, it will be in this position. And if you come back at 2 o'clock in the morning, it will be there. And if you could see it during the day, let's suppose there is a total solar eclipse and the whole sky is dark, the star will be there, and that's Polaris. Perhaps not the brightest star in the sky, but it is always there because it's the star through which the axis of the Earth passes, so the Earth rotates around it. And it's quite interesting and good to know, because if you identify Polaris, the shortest piece of the sky between the star and the horizon will point you to where north is. And we can run into really interesting situations here, because if you are in the North Pole, for example, Polaris will be exactly above your head. And if you are able to measure how high Polaris is above the horizon with the sextant, you know immediately your latitude, like how high are you above the equator, roughly speaking. So that's a very useful star, and it has been used, and it was used by astronomers and navigators over the past centuries. It's really a remarkable star in the north. In the south, well, in the south, we have a very serious problem because we don't have a south polar star. We have a few constellations which are brighter, and in my opinion, a couple of them are really pretty, like the Southern Cross that you see here in this image. This is really a great image made by a great astrophotographer that works in a telescope in Chile. So you have here the pointers, which are Alpha and Beta Centauri here, very bright stars. And if you take those two, and then you go to the right of those stars, or if you follow the somehow line that they make, you will hit the Southern Cross. Southern Cross is really important because it has many bright stars. There are other asterisms like the false cross, but one way to differentiate between the false cross and the true cross is the false cross has less brighter stars. The false cross is a bit bigger, and the false cross does not point to the south, while the right one, the Southern Cross, it points, the larger arm points towards the South Pole. So if you manage to identify the Southern Cross, you can use it to find the geographical south. I'm going to come back in the next slide to the Southern Cross. But before, I want to use the brightest star in the sky, Sirius, and the second brightest, Canopus, also to help you to find the South Celestial Pole. If you make a line between Sirius and Canopus in one of the trips we do in the south, this can only be done in the south, in Ushuaia or in Antarctica. If you make a line between the two, more or less, if you duplicate the distance between Sirius and Canopus, further south, you will hit the South Celestial Pole. And that area, the shortest path between the pole and the horizon will give you the geographical south. And that's another way to find the south. Using the Southern Cross, you can, here is the Southern Cross. It has 3 really bright stars and the pointers here. And if you make a line between the Southern Cross and another little star called Achernar, more or less halfway through the line, you will find the South Celestial Pole. And again, if you make a line of the South Celestial Pole with the horizon, there you will have a south, like the direction, the compass direction. So that's another way to find the south. Sadly, in the southern hemisphere, there is no south polar star. Actually, technically, there is one, but it's so faint that you really need to have very good eyes. It's on the edge of what normal people can see with their eyes. It's Sigma Octans. It's really a very faint star in the South Pole. So, and this is what I was telling you before. If you see many bright objects forming lines, that means that they are probably planets. And in this case, we have Mars here. It was not so bright, but we have very bright Venus here and Jupiter along the ecliptic. And the ecliptic is, again, the line is composed by 13 constellations, the normal zodiac constellations, plus one that nobody wants to talk about it, the keeper of the snakes, Ophiuchus. But those constellations make the ecliptic, and the planets will always be somewhere along this line. Also, the path of the sun around the year follows this line, and This is important to know. If you see very bright planets at noon, at midnight, for example, it's very likely that they are either Jupiter, Mars, or Saturn. Remember, Venus and Mercury are only visible after the sunset or before the sunrise, and that's because they are inner planets. Whenever we have another chance, I can expand and explain you in more details more about observational astronomy. But again, in this presentation, I just wanted to give an overview of what you expect up there. So the night sky offers also meteor showers. And we just missed one that happened on the 26th of April. It was the Leonids or Lyrids. It's not so significant meteor shower, but through the year there are many different. And whenever we are on board and there is one, there are ways to know about it. It will be on the list of data I'm going to send you later. But the important thing is when you have a meteor shower is because the Earth is passing through an area where you have debris from comets or a clump of small meteors. And normally there is a peak. Normally the meteor showers, they have a peak. So that's the moment where the Earth crosses the higher density, the area of the cloud with higher density, and is when you see more meteoroids or shooting stars. And the peak, what is important with a meteor shower is to time it, to know when the peak is, and to be able to observe the peak where you are during the night. Because if it happens during the day, it's impossible to see. The picture here is from a meteor shower that happens very early in the year, the quadrantids, and you can see here many shooting stars. A shooting star, if you are wondering what it is, a shooting star is a tiny particle, normally made of can be metallic from iron, iridium. It can be also like little sand, like made of silica, and they enter the atmosphere at very high speeds. They travel normally at 60,000 kilometers per hour, so really fast. It's really unimaginable, the speed at which these tiny particles can travel. And when you combine the movements of the Earth plus the movement of the meteorite, then the combined velocity can be even higher. So they travel so fast that they penetrate the atmosphere of the Earth, and then as they start to cross the layers of air of our atmosphere, they heat up until the point that they explode, they disintegrate, and they produce lots of friction and heat. And at these speeds, the heat just ionizes all the gases in the higher atmosphere, and that's what you see here, the trail of the meteorite. This is the disintegration. The ionizing is so fast that it just ionizes everything that encounters, and it produces this beautiful streak of light. They can be really powerful, really impressive. There is one around November, the 17th of November. It's called the Leonids, and this is really one of the most spectacular ones because you can even feel like someone is making pictures with flash up in the sky, because you can see the really bright flashes and shadows and really trails of the meteorites passing by. It's really impressive. I had a chance to see once in '95 Leonid meteor shower, and I really encourage you, whenever you are around the 17th of November, try to look towards Leo, the constellation of Leo, the lion, and then you might enjoy a beautiful display of meteors. So if you missed any of the meteor showers, don't worry, because in a normal night you have the chance to see about 20 shooting stars. So just be patient. Remember, just everything you need to do is look up and enjoy and be patient, because sooner or later you will be rewarded. Other objects that you can see, these ones are particularly in the south, and I have had the chance to point to you a few of you. The Magellanic Clouds are the small Magellanic Cloud and the large Magellanic Cloud, which appear as two nebulas close to our Milky Way. our Milky Way, of course, we can see it everywhere in the northern and in the southern hemisphere. And what is interesting of the large and small Magellanic Clouds is that they are two satellite galaxies of our Milky Way. So in the south, the most distant objects that you can see with your eyes are the Magellanic Clouds. They are really far away, about 175,000 light years away from the Earth. And this is a small and the large Magellanic Clouds. You can see here the Southern Cross. And you can also contemplate here in this image a very dark spot here. These are regions where you have dust, really like soot, like really black dust that absorbs the light of the stars behind. And then it provocates like it's a hole in the sky. And this is called the coal sack. And this is a really cool feature of the Milky Way in the southern hemisphere. So you can also enjoy a couple of clusters. One of the most beautiful is the Pleiades. This is a really great picture that shows you the nebula around. With your eyes, sadly, you cannot see the nebula, but you can see the blue 7 bright stars of the Pleiades. That's in the north. And in the north also, I found this great picture of an astronomer in Australia, where you can see here Andromeda. This is a galaxy, and it's only visible or mostly visible from the north. You need really special conditions to see it really south, because it's always low in the horizon. But what is important of Andromeda, and by the way, my background is Andromeda. You can see it here on my back. And Andromeda is, what is important is that you can see it with your eyes, and it's the most distant object that your eyes can see. And the distance is absolutely incredible. It's 2.5 million light years away. So that means the light of this object, when you see it, it has been traveling for 2.5 million years. So it's light of a time where there were no humans on the surface of the Earth and no hominids. And it has been traveling for a long time. And this is really the most distant thing that your eyes can see in a clear night. And it looks like, if you have the right conditions, it looks like a fuzzy star in the constellation of Andromeda, close to the square of Pegasus. So I will send you some charts so you can enjoy looking at it. Of course, one of the queens of all the sights, probably in my opinion, one of the most beautiful things that your eyes can contemplate are the polar lights. A question I get always on ships from passengers and from some colleagues is, can you see Aurora Australis in Antarctica? And sadly, not from where we go, because they do happen in Antarctica, but you really need to be deep into the continent to be able to see Aurora Australis. Most of the auroras that we see are in the north, and most of the pictures that we see from auroras are from the north, because the north has more access, is easily accessible from air or from ships. And these are really spectacular phenomena. I can talk to you about this for days, but basically you have particles from the sun coming and interacting with the magnetic field of the Earth. And this is they produce these beautiful streams of light and these beautiful displays. This picture is from one of your colleagues, Lothar. Thanks, Lothar, for the picture. I took the liberty of including it because it was really a beautiful picture. So I have spoken a little bit about the day sky, the night sky, the special phenomena, and I want to conclude. I have been speaking now for almost an hour and a bit. So I want to conclude giving you a little overview of the day sky and what do you expect to see in the day sky. So you can see an omega sun like this one. This looks like there are two suns, but the sun is too low and there are the right conditions of humidity and temperature and layers of air above the horizon that they can produce reflections of the sun. And it looks like there are two suns. And again, I'm going to show you just briefly a few of the things, crazy things that you can see in the day sky under the right conditions. Such as you can see, for example, these pillars of light that happens. They happen in northern regions when you have very cold air with ice, and they reflect, they multiply, they beam literally the light to produce these really crazy sights. And you can start, for example, I invite you to look for Venus during the day, for example. This is, it looks like a tiny diamond suspended from the sky. And if you know that Venus is going to be close to the moon, you can use the moon to find Venus. And it's quite an interesting sight. Many people think this is a UFO, but this is just Venus. It can be so bright that it can shine in the day. A very common question and phenomenon that happens, well, common question, not so common phenomenon because it's quite hard to see it, is the green flash. So people think there is a myth or something, but I personally have seen a few, not as much as I would like, but I have seen a few during the trips at sea and also once in the mountains. And you can see here, this is the horizon. This is the sun setting. And the green flash basically is literally a flash that lasts, as I will quote a friend of mine, as long as you take a deep breath. That's the time it lasts. It's a very short flash of green light that happens exactly at the moment when the disk of the sun, the upper disk, the part of the disk of the sun sets below the horizon. So you need to be really at the right time, at the right moment to do a picture like this. Once I'm showing you this, Andrew Young, he's a guy who is crazy about doing pictures of green flashes. And he has devoted most of his life to do pictures of green flashes. And this is one of the best he has gotten. And you can see that really is green. And it's quite an interesting phenomenon. I have had a chance to do a picture once of one. Is this one in the South Atlantic, close to Tristan da Cunha. It was really the right conditions. Again, it's a play between light and layers of air of different temperature in the atmosphere and the sun setting. And that's how it looks like. It's really green. This was not so long, but once in port, I was somewhere in a port in Brazil, in Fortaleza. And then as the sun was setting on the horizon above the sea, there was the best green flash I have seen. It lasted at least a second and a half or 2 seconds, I don't know, but it lasted a long time. And it was really, really emerald green. Sadly, I didn't have my camera, but that's another one I remember. And also at the top of a mountain once, I saw a green flash. This is also possible. You don't need to be at sea. You need to have the right conditions of layers of air, cold and warm air, and the right setting for the sun. So that was regarding the green flash. So again, anytime you want to talk more about the green flash, you know where to find me. I want to talk the last slides. I want to talk about the interaction between water, light, and the sun. And water, as you know, it can be found in different forms. You can find it frozen. It makes crystals, different types of crystals. You can see here from plates and snow to solid plates, hexagonal solid plates or hexagonal bars of ice crystals. And then you can have it also liquid, like in water droplets in the atmosphere, and you can have it in vapor as a water vapor. And depending on the types of crystals, when they interact with light, and depending on the orientation of these crystals, you can produce really crazy things in the sky. So a reminder of light, if you remember, white light is the superposition of all the colors. That means all the colors are traveling at the same speed. But when you make white light pass through something like an ice or a crystal or a liquid, then the light, the colors feel the substance, and then some colors travel faster and other colors travel slower, and then you get refraction, like the famous disc of Pink Floyd, The Dark Side of the Moon. You get this nice refraction here, and you get the composition of the colors, just because they were traveling at different speeds through the medium. And then this is called a spectra. And when you mix, for example, light and water in the atmosphere, you can produce rainbows like this. really a double rainbow. You can see a beautiful rainbow, really bright, and a double rainbow. And what is interesting is that you can see the pattern of colors. The inner bow goes from blue to red, and the outer bow goes from red to blue. And that's really remarkable because it's a double reflection, and this is a double rainbow that you see here. This was made by someone. I found it on the internet. Sadly, it had no author, but it's a double rainbow at the Strait of Magellan. Sometimes when you have ice, ice plus light gives you halos like these ones, a beautiful ring around the sun, normally at 21 degree halo. But the orientation of these crystals and the shape can make really incredible things, like the one I'm going to show you next. Imagine that you wake up in your home and you see this crazy thing from your window. Probably I will say, oh, I had too many beers, or I don't know, I took the wrong pills, or so, I don't know. But this is really beautiful. I never had the chance to see such a complex parhelia and halo and sundog all together. But such a complex, I have seen parts of it. I have seen sundogs or Parry Arcs or circumzenithal arcs, but not all in once like this one. And this can be seen in polar regions when it's really cold, and when you have the sun under at very low in the horizon, and it can be visible. And just a little anecdote: this Parry Arc here. Parry was a sailor from the British Navy, Edward Parry, and he was the first one to go very far north. He reached 75 degrees north in 1624. So he was really early. He was very lucky. And in his diaries, he describes these arcs of around the sun. Nansen also, in his books, mentions many of these halos and pillars around the sun. So you can also see anti-crepuscular rays. That's the name for this. I'm sure many of you have seen this. This is called a glory. Is when you look down in the anti-solar point. That means the sun is behind me in this picture where I have the mouse. That's a glory. Is also called a corona or sun corona, but nobody wants to talk about corona, so we call it glory. And you can also have sun pillars like this one here. That the sun is setting in the picture, but it can make like if you have dust or particles, they can really multiply the reflections in a certain direction and make like a pillar of light. And sometimes you can have also really high clouds that are frozen, and then when they interact with the light, particularly horizontal beams of light, then they produce these nice iridescent clouds or colors. Two slides to finish. One of the most beautiful things you can enjoy in Svalbard or in Greenland when it's really cold and sunny is this kind of images. These are mirages, and you can see, for example, crazy things like floating islands like this one, or you can see reflections like this. If you make a line here, this is really the reflection of these hills here. And here, for example, you have really reflections that make this look really tall. Once I did a game with some of the guests. We measure the distance towards the big chunks of ice from the bridge with radar, and then with a sextant we measure how high this ice looks like, and then roughly speaking, and then we got a number like this ice was like 5 kilometers tall, and it's just a mirage because this is sometimes when you have the right conditions of again, layers of air of different temperatures and light, you can produce reflections, or you can do stretching of objects. And so objects look taller as they are in reality. Another thing is like ghost ships. Like, you know, probably some of you know this ship. This is the Polar Cecil. You know, it's like, looks like it's floating in the whole hull is gone. It's like floating above the horizon. And that's also a reflection and twisted. Is the light and the air playing with us. Here I also offer you a nice reflection here. You can see here this is really symmetric, and this is nothing but the reflection of the hills in the horizon. Again, because the light from the hills is passing through air that has different temperatures, therefore different density. So the air makes the effect of a lens. So I reached the end. I really thank you for your patience. I hope it was not a marathonic session, and I hope you enjoyed as much as I did. I really enjoy talking about this because this is my world, and it's so nice to be able to share it with you. And then I have a final test for all of you. It's the Mirage Cat. So how many cats do you see there? And this is a really beautiful picture because you can see everything I mentioned in the previous slide in one single picture. You see there reflections of the cat. You see also the stretching of the cat, and it looks really crazy. So how many cats do you see? Or does your answer depends on the number of drinks you have already had? Because I think it's time for a drink. So you see 1, 2, 3, 4, 5 cats. And you see, for example, this is right, that is like up. This is upside down. And here you see some stretching, so the cat looks a bit bigger. And here you have symmetric reflections of the cat in this tree upper. And this is very easy. You can do it. You can, for example, put vodka in the bottom, water and water with sugar, or you can play with glycerin, and you can make, the only thing is that all the liquids need to be transparent, and you can pour them gently so they don't mix too fast. And then you can play with liquids with different density, and then you can play the mirrors and have some fun at home. So really, thank you very much again. Thanks for your attention, for watching. Enjoy watching the sky.